Okay, now let's look at using the law of cosines to solve some triangles here. Okay, so basically the law of sines is always useful when you have two sides. You're given two sides in the included angle. So that kind of jumps out, oh yeah, I can use law of cosines. Okay, and notice you wouldn't be able to use the law of sines because you would need at least one side and the opposite angle in order to set up a proportion. And you don't have that here, and there's no way to get like one of these angles, okay, from the law of sines or this side. So really, this is a situation where you can't use the law of sines. You would actually need the law of cosines. So the two rules go together very nicely. So the way that you would use the law of cosines then is this could be your C. This side would be your C. And then I could say that C squared is equal to, this is your A and B, so it'd be 12 squared plus 10 squared minus 2 times 12 times 10 times cosine of 23 degrees. So you get all of this stuff. So then you would need your calculator to calculate that. So I would have 12 squared plus 10 squared minus 2 times 12 times 10 times cosine of 23 degrees. And putting all that in, I would get, in this case, all of that is equal to like 23.07883517. Probably goes on, it's an irrational number. So then you're going to take the square root of both sides, and of course you only want the positive square root. So I'm going to just raise that to the half power, and I get like 4.8, and we'll just round that to the tens place is good enough. 4.8, and so that would be this side over here, 4.8. Okay, and that's the idea of the law of cosines. Now, actually, if I wanted to solve the triangle, I would need one of these other angles, and I could use the law of sines now, because I have, let's say, this side opposite of that. Let's see here. I would have, I'll find this angle. Okay, we can call that alpha. And then I would have the sine of alpha over its side, 10, is equal to the sine of 23 degrees over 4.8. So you would get this. And so I'd get sine alpha is equal to sine of 23 degrees over 4.8 times 10. And all of this here is sine 23 divided by 4.8 times 10. And this whole thing is like 0.814. Okay, so then I could do sine inverse of 0.814. And I get like 54 degrees. 54.5 degrees. And that would be reasonable here. 54.5 degrees. You could get the other angle over there by subtracting from 180. And then you've solved the triangle. Now this could have also been a ambiguous case. So there's another solution that I think would have worked here, but if I trust my diagram at all, that would be the right angle, because there's no way that angle is going to be greater than 90 degrees. So I wouldn't worry in solving that. I wouldn't worry about the ambiguous case. Okay. So hopefully you're able to see all of that on the screen there. So let's go ahead and do this. This is a situation where you're given a side, side, side. Okay, you're given 3 sides of the triangle, and so what you need to do is just pick out one of these angles, and you're going to find that one, and you're going to use the law of cosines to do it. So this is like your C, so I'd get like 3 squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 times cosine of theta. So I'm just treating this as my A and B, that's my C, and I'm setting all of this up, okay, and then I'm going to solve for that cosine theta. And to solve for that cosine theta, what it basically amounts to is moving these two to the other side. So you get the 3 squared minus 5 squared plus 7 squared all over, and then you divide by this here. Minus 2 or negative 2 times 5 times 7. So I move those over and then I divided by that to solve for this. And then you can get whatever this is equal to. Let's see. So 3 squared minus 5 squared minus 7 squared. This should have been a minus, by the way. Sorry. And then I'm going to divide this by, I got to make sure this whole bottom is in parentheses, 2 times 5 times 7. And I get like 0.929 if I round to 3 decimal places. And so now I can solve for the theta. And so this would be cosine inverse of 0.929. So cosine inverse 0.929, and I get that this is approximately 21.7 degrees. So 21.7 degrees. And then you could go and you could find the other angles as well. You could just use the law of cosines again if you wanted to, find one more and then find the last one. You could also use the law of sines. Okay, but that's the idea. And in this case, there's no ambiguous case because this will either be an angle between 0 and 180. Okay, so for the law of cosines, when you solve here, you're not going to get 2 solutions like you would the law of sines. So for that reason, I usually like to go ahead and use the law of cosines. So let's go ahead and do that. We'll find this angle now. Okay, I could call that alpha or whatever if I wanted to call it alpha. And so what I would have here is 5 squared is equal to 3 squared plus 7 squared minus 2 times 3 times 7 times cosine of alpha. And then I get cosine alpha is equal to 5 squared minus 3 squared minus 7 squared all over negative 2 times 3 times 7. And so I get 25 minus 9 minus 49. Divide that by negative 2 times 3 times 7. And I get that this is like 0.786 if I round to 3 decimal places. So my alpha is cosine inverse of 0.786. So cosine inverse of 0.786 is equal to 38.2 degrees. So that would make this 38.2 degrees. And then you could get this angle. It would be 180 minus 21.7 minus 38.2. It looks like this is 120.1 degrees. Okay, and so that would be solving that triangle. Okay, so this is what you would use for doing an SAS or an SSS triangle. So now in the next couple videos we will do some application problems involving the law of cosines.